Hello everybody, welcome back to our channel. In this episode we're going to be solving a Physics 7B torque practice problem. So let's just go ahead and read what the problem says. Feel free to pause the video in order to be able to copy the problem on your notes. This is quite a long problem, so let's just go ahead and read it out. So at the end of the 1969 movie The Italian Job, the bus containing Charlie and $4 million in gold he stole in Turin and so balanced on a cliff as shown in the picture below. So the gold has a certain mass, the bus has another mass, and for the purposes of this problem, you can assume that the mass is evenly distributed throughout the bus. The bus is 12 meters long, and the gold is located exactly 1 meter from the back of the bus. Charlie, who is standing right above the pivot point, has a mass of 70 kilograms. So the first two questions that we're going to answer are: first, find x, the distance from the front of the bus to the pivot point. Second, find the magnitude and direction of the force on the bus at the pivot point. So as you can see, I have everything written down here in my notes. So I have the little drawing. So this is Charlie. This will be the gold. The gold is 1 meter away from the back of the bus, and the entire bus is 12 meters. I copied the masses of the gold, the bus, and Charlie over here. And I also did a little bit of an extra drawing that, should be self-explanatory just in 1 second. So let's just go ahead and start this problem. So I think that the best way to start this problem is by just figuring out what are the forces that are acting on the bus. So the first force that is acting on the bus would be the weight of the bus itself. So the bus has a certain mass, therefore it does have a certain force by gravity. So let's just go ahead and do that. As usual, because the mass of the bus is evenly distributed, that means that we're gonna place force by gravity exactly at the center of the bus. So that would be over here, 6 meters away from each end, exactly at the middle. So I'm just gonna go ahead and do that. F by gravity, and force by gravity is just equal to mg. So if the mass of the bus is this number times 10, that is just gonna be 128,000, because this is just mass of the bus times gravity, right? And it's going down. Okay, so next we have some gold here. So the gold is over here, exactly 1 meter away from the back end of the bus. So let's just go ahead and do that. The mass, the force that the gold is putting on the bus is just its own weight. So that will just be this number multiplied by 10. So this is force by gold, and the number is just 32,000. Now the next thing would be Charlie. So Charlie has some weight to him, so I'm just gonna go ahead and copy him. He's only 70 kilograms, so force by Charlie, 700 newtons. So that's 3 out of 4. Now, how do I know that there has to be a second, another force besides the fact that, I'm supposed to find it at some point? Well, the problem says that this entire structure is stationary, which means that it is not moving in space, and it is also not rotating around the pivot point. This means the fact that it's not moving in space means that the net force has to be equal to 0. And the fact that it is not rotating around the pivot point means that the net torque is equal to 0. There we go. So this is how I know that the forces have to add up to 0, and if we have 3 forces going down, they are of course not gonna add up to 0. So we do have a big force going up, right? So let's just go ahead. And so it should be the magnitude of this combined. So I'm just gonna go ahead and draw it big. And actually, I can figure out what this is right away, right? Yeah, because I have this force, and this force. So I could just go ahead and do part B right now. Huh, that's interesting. Well, let's just go ahead and do that then. Yeah, if you don't mind. So for part B, we need to find force by pivot. And we know that the net force has to be equal to 0. So a force going up minus a force going down minus a force going down minus a force going down has to be equal to 0. So that means that force by pivot just has to be equal to let's see, 32 plus 700 plus 128 and down. Alrighty, so 160,700. So there we go. Magnitude and direction of the pivot force. Alright, so that was unusual, but let's, I mean, we'll take it. We'll take a victory if we can. So let's just go ahead and go back to solving this X. So as you can see now, all of my forces are here. This is a complete force diagram. Every single force has been figured out. And I do need to find this X. Now, the thing that's awkward about this problem is that it does require some sort of, you know, spatial awareness. So we know that the torques have to balance out, right? So our torques need to balance out. So let's just go ahead and write this equation. The net torque needs to be equal to 0. Now, out of these 4 forces, how many of them generate a torque? Well, out of these 4 forces, only this force, force by Gould, and this force, force by gravity, are generating a torque, because force by pivot and force by Charlie are being applied at the pivot point, which means that there is no moment arm. R is equal to 0. So these 2 forces are not going to show up in this equation because R is equal to 0. Now let's just go ahead and write these 2. So the torque by the Gould and the torque due to gravity have to add up to 0. Now let's just take a second to figure out the direction of these torques. So this torque right here, the one by the Gould, if we just use our right hand rule, that is going to be a torque going out of the page. So this is an out of page torque. Torque by gravity is going to be a torque going into the page. So that is going to be torque into the page, and this should make sense, right? Because they have to add up to 0 in order for it to stay put. So it does make sense that, you know, these 2 have to be opposite signs right here. Now, our usual convention is that out means positive, in means negative. So I'm just gonna go ahead and use that convention, but you know, feel free to do it the other way around. Both of them are equal to 0, so if you just flip both of them, then you're still gonna get the same answer. So R to the Gould times F due to the Gould, which I already have a number, so I'm just gonna copy that number, minus R to the gravity point times the gravity force is equal to 0. Now here's the problem, and here's where a lot of people got stuck, and this is basically why I decided to you know, label this problem as a red problem, as a difficult problem. So we have an equation that has an R to a Gould, a moment arm to the Gould, and we have an equation that has a moment arm to gravity. So in terms of my diagram right here, so as you can see, I have 12 meters total, so this entire thing is 12 meters. This chunk right here is 1 meter, which is the distance from the back of the bus to the Gould. This half right here is 6 meters. because this is, you know, this half of the bus, and this is exactly at the middle, so this has to be 6. And x was just given to me by the problem. It is the distance from this side of the bus to the pivot point. Now, our goal in terms of this diagram would basically be this right here, because it would be the distance from the pivot point to the goal. And our gravity would basically be this distance right here. It would be the distance from the pivot point to the force of gravity. So I do know what our goal and our gravity mean in terms of this context. The only thing that's going to be challenging, or that was very challenging, is that we have to write these two guys in terms of x, because otherwise, well, we're not really going to be able to figure out x from this, right? We're not even going to be able to figure out anything, because we have two things that we don't know and just one equation, so we would essentially get stuck. So let's just go ahead and try to solve, or just try to figure out what our gravity and our goal are in terms of x. Now, this is the reason why I decided to copy this diagram right here. So as you can see, we have a little equation that's going on just in this side of the bus, right? Because x is over here, and we have 6 meters over here, and we have our gravity over here. And essentially what this is telling us in terms of an equation is that x is equal to 6 plus our gravity. Because if you add 6 plus r, that's going to be equal to x in length, right? Well, this just means that our gravity is equal to x minus 6. See what I did there? If you have x and you take away 6, then you get our gravity. Now we're going to go ahead and do something very similar for the gold. The only thing that we're missing over here is that this 1 meter is not really very useful, because it's a distance from the back of the bus. So what would actually be useful in order to be able to use this exact same logic would be, if this is 1 meter and the total is 12, then this distance has to be 11 meters, right? So 11 plus 1 is equal to 12. So this distance has to be 11. And we can go ahead and pretty much use the exact same logic, except that now 11, which is this total distance, is equal to R2 gold plus x. So I'm just going to go ahead and write that. So 11 is equal to x plus r gold. If you have x and you add r, then you're going to get this 11 meters. So I'm just going to go ahead and solve for my r. So r is equal to 11 minus x. Beautiful. So now I'm just going to go ahead and copy that on this equation. So our gold is 11 minus x times 32000, and our gravity is x minus 6 128,000, and this has to be equal to 0. There we go. So now basically all I have to do is factorize. Yes, so let's just go ahead and do that. Okay, let's see. So 11 times 32000, that is 352,000 minus 3200 x, and then this is minus 128,000 x, and this is minus minus plus 128,000 times 6 is equal to 768,000, has to be equal to 0. So now I'm just going to combine these two and these two. 76 plus 352,000, that is equal to 112. Now 128,000 plus 320,000, that is equal to 160,000. X is equal to 0, so x is just this number divided by this number. So 112,000 divided by 160,000, and that is going to be equal to 7 meters. There we go, final answer. So there we go. So that is part 2 of this problem, 7 meters. So this x has to be equal to 7 meters, which means that so let's just go ahead and write that down. Perfect. So this is equal to 7 meters. Perfect. All right, so let's just continue with our problem. All right, so let's see. So there is actually a part 3 to this problem, so let's just go ahead and read that. So in order to get the goal, Charlie attaches a cable to the front of the bus as shown in the picture below, which is this picture over here. What is the minimum tension the cable must be able to withstand in order for Charlie to be able to walk out of to where the goal is located without sending the bus toppling over the edge of the hill? Please remember that Charlie has a mass of 70 kilograms. Okay, so for this we basically need to do another extended force diagram. So let's just go ahead and redraw our extended force diagram. Let me just go ahead and write that this distance was equal to 7 meters. This was our answer to the last part of the problem. And if this is equal to 1 meter, then this has to be equal to 4 meters. Because the entire length of the bus was equal to 12, right? And this has to be equal to 1 meter. Yes. Is it equal to 1 meter? Okay, so x is equal to 7. Yes. Yes, so this has to be equal to 1 meter. Alrighty. Okay, so these are my distances that I figured out on part 1. Now, the boy moves, so Charlie moves, so that is basically gonna change our entire thing. And we basically need to figure out a tension force. So for this part of the problem, we have a force going down over here, which is force of gold plus Charlie. We do have some force by gravity over here. Same as before, the mass hasn't really changed, so this is 128,000, and actually these two is just their combined weight. So I'm just gonna go ahead and combine their weights. That is 32,000 plus 700, so that would be 32700. We do have some force at the pivot, but that is not necessarily a concern at this point in time, and we have to figure out what is the force due to the tension. So first of all, what would be the direction of the tension force? Well, it would be down because Charlie put up a cable right here. So let's just go ahead and figure that out. Let's just call it T, tension force. So yeah, so basically we just need to balance our torques again. And that's gonna be it, right? Yep, that's... So Charlie doesn't want this thing to move, which means that essentially what he wants in terms of physics is that the net torque has to be equal to 0. Now before we had 4 forces and only 2 of them were generating a torque. In this particular case, we have 3 forces generating a torque. So let's just go ahead and write those down. So this would be the torque due to Charlie plus gold plus the torque due to gravity plus the torque due to the tension force has to be equal to 0. Now this torque is gonna be out if you use your right hand rule, so this is positive. This torque is going to be into the page if you use the right hand rule, so negative, and this torque is gonna be going into the page if you use the right hand rule, so that is gonna be a negative as well. So let's just go ahead and write our equation in terms of RF, or R perpendicular F. So the first R is equal to 4 meters, and the force is equal to 3,700, which is the combined weight of Charlie and the gold. Now the next is R to our gravity. We figured that one out on the first part of the problem. It's just 1 meter, and his weight is this is negative, he's going into the page, I'm sorry, 128,000. Now the other torque is the torque due to the tension. We know that this distance over here is 7 meters because it's X, and obviously we don't know the tension force, so all of this has to be equal to 0. So I'm just gonna go ahead and solve for that. So T has to be equal to 4 times 32700 130,800 minus 128,000 divided by 7 minus 128,000 divided by 7. So that is going to be equal to 400 newtons. Final answer. There we go. So that is going to be the final answer for part 3 of this quiz, but there is a 4th part of this quiz. This was a little bit of a long quiz, but let's just go ahead and read that. So Charlie then lifts off the 20 kilograms of gold and carries it back with him to the pivot point. Describe what would happen to the bus as a result. Okay, so basically what we have is that Charlie is here with the gold, and then he decides to move here to the pivot point. So what is going to happen to the bus? Well, if Charlie moves, that means that this force, let me just go ahead and use another color. If Charlie moves, that means that this arrow, so this force is gonna move over here, right? If this moves over here, then I only have 2 forces generating a torque. Torque by gravity and torque by tension force. So when Charlie moves, we only have 2 torques left, plus both of the torques are going in the exact same direction. And because 2 vectors going in the same direction can't add up to 0, that means that on part 4, the net torque is not going to be equal to 0. In fact, the net torque is going to be pointing, so these 2 are into the page. And because this system has an unbalanced torques going into the page, that means that the bus will start rotating. Now, how do we know in which direction is it going to start rotating? Well, you just point your thumb in the direction of the net torque, and then you twirl your fingers. If the net torque would be out of the page, that means this direction, but because my thumb is pointing into the page, because the net torque is into the page, then the bus is going to start spinning clockwise. We'll start rotating. The bus will start rotating clockwise. And there we go. So finally, we're done with this problem. This was a little bit of a challenging quiz. Very 7B, very typical 7B problem, but definitely on the harder part. Particularly, just solving this geometric situation that was going on at the beginning. But hopefully this video helped you out, and if it did, please leave a like and subscribe to our channel. It helps our channel a lot, and please feel free to make some suggestions of what would you find helpful. So anyways, I'll see you guys on the next video. Bye.